I've been asked what I think about nutrient density scales. Here's what I think. The point is to minimize calories and maximize nutrients. The reason for that is that given equal amounts of muscle, the longevity literature, the evidence from the longevity literature seems to suggest that lower caloric intakes across a broad number of species and suggestively in humans maximizes longevity and almost certainly maximizes health span. Again, given the same amount of muscle in two different individuals, you're going to want to, the individual that is minimizing the calories the most is probably the one that's going to end up being healthier. There are caveats to this. It's possible that this association changes with age. It's possible that there are brain-specific effects to caloric intake that might make us somewhat less enthusiastic about this particular paradigm, such that, say, for example, say you're decreasing IGF or other growth factors by caloric restriction, which might be very good for preventing cancer and other diseases. However, you may also be inhibiting neuronal longevity or neuronal health span, brain health span. So from this point of view, it's not entirely certain that you're necessarily want to get to the lowest possible caloric intake. I will say this: if you do have a relatively low amount of calories, but you are getting quite a lot of exercise, if there are some concerns about lower caloric intakes resulting in poor brain health, this should mitigate them at least to a certain degree. We do know that excessive caloric intake certainly does harm brain health. So the question is if we're going to employ the Goldilocks principle here, what is the happy medium at which we can maximize the different health span variables and longevity variables so as to produce optimality? And that's not known. Given that we're going to assume that we want to minimize calories, but perhaps not minimize them to the absolute minimum, but to some minimum that allows us to balance certain moderate or maybe even high level of physical activity with this low caloric intake, I do think that all else equal, we want to look at nutrient density scale in terms of calories and not volume, and that's because of the importance of calories and the relative non-importance of volume. So from this point of view, all else equal, nutrient density by calorie seems ideal. If one needs more calories, one should simply eat down the scale, but as high as possible given higher caloric needs. That said, nutrient density scales seem to depend heavily on prior assumptions. Even Marty Kindle uses essential amino acids as important contributors to nutrient density. I don't agree with this. Amino acids are impossible in a normal person. Amino acid deficiency are impossible in a normal person on a whole food diet, and some evidence suggests that amino acid intake can be too high. The question shouldn't be how high can I get my amino acid intake, which is, again, if I understand correctly, rewarded by Marty Kindle's nutrient optimizer scale. But the question is what amino acid intake is optimal? And again, going back to this invoking another Goldilocks principle, assuming that higher is always better is questionable from an evidence-based point of view. Not just invoking that principle, but also looking at the evidence. Likewise, the problem of diminishing returns or even harm at high intakes for other minerals such as iron, zinc, copper, and other transition metals. What is the optimal intake of these? Is more always better? And is it really a reasonable assumption that plasma levels of these transition metals are carefully enough regulated to be unconcerned about high intake? If so, I want to see the evidence for that. The evidence I've seen points to an association between high plasma transition metals and disease. All this suggests that there isn't such a thing as a linear nutrient density scale. Essential nutrients that might be beneficial at low intakes may show diminishing returns at moderate intakes, and an optimal nutrient density scale needs to be able to account for that, and then harm at high intakes. Again, the nutrient density scales that I've seen haven't well accounted for this. This suggests that nutrient density scores for foods can only approximate optimality, and that to be truly accurate, we need nutrient density scores for particular dietary patterns. These would take into account the non-linearity in benefit and harm from different nutrients. And in fact, even as we discussed at the beginning, the non-linearity in benefit and harm from calories. So that would be my take on nutrient density scales.